In this question, we'll use inverse matrices to solve the following pair of simultaneous equations. Let's write down the formula for our inverse matrix. So if we have a matrix which is A, B, C, D, then the inverse of the matrix is 1 on the determinant multiplied by D, negative B, negative CA. And the determinant is AD minus BC. We'll use that soon. The first thing we'll do is set up a matrix equation. We'll let the coefficient matrix be 5, negative 3, 2, 5. So those are simply the coefficients from the equations. We'll let the variable matrix x be xy. And the constant matrix is negative 13, 1. So let's write it out. We have 5, negative 3, 2, 5 as our coefficient matrix multiplied by the variable matrix, which is xy, equals our constant matrix, which is negative 13, 1. Let's check it's correct. When we multiply two matrices, we multiply the rows to the columns, and we'll get this value coming out as our output. So 5 times x minus 3 times y equals negative 13, which is indeed the first equation. So this is the correct setup. So what we have is matrix A times matrix X equals matrix B. And we want to find matrix X. So what we have is matrix A times matrix X equals matrix B. As we want to find matrix X, we need to isolate it. So we do that by pre-multiplying by the inverse of matrix A. Any matrix times its inverse is the identity matrix. So we have IX equals A inverse B. And the identity matrix times the matrix will just be simply the matrix. So X equals A inverse B. So to find our required matrix, we have to multiply the inverse of A to B. So let's calculate our inverse matrix. The first thing we need to do is get the determinant, which is AD minus BC. So det A, we'll write that here, is AD minus BC. So that's 5 times 5 minus negative 3 times 2. That will give us 25 plus 6, which is 31. So our inverse matrix is 1 divided by the determinant, which is 31. Now observe how we change the values. We have 5 and 5. These two numbers are swapped. Well, that means they don't change because they're both 5. And then we change the signs on the other diagonal. So this will become 3, negative 2. Now we can leave it in this form. We don't need to multiply the scalar to each element. So we have A inverse times B. This is what we need to calculate to find our required matrix. So we have 1 on 31 times 5, 3, negative 2, 5 times B, which is negative 13 times 1. Now we'll do some matrix multiplication. So we have 1 on 31 times 5 times negative 13 plus 3 times 1. So remember, rows by columns. And then we have negative 2 times negative 13 plus 5 times 1. So you'll get 1 on 31 times negative 62 and 31. So when we multiply by the scalar 1 on 31, we'll get negative 2 and 1. So these are the values of X and Y. Thanks for watching.